So,
Always
all
too.
right. Thanks again, all.
Absolutely. All
Thanks
right.
again.
Thank you.
Yeah.
Bye-bye.
Yeah. So, real quick, everyone, we're heading into the breakout now where you can split between track 1 and track 2. And first, I just wanted to say again a big thanks to our planning partners. Huge importance to them. I forgot to mention them. Architectural Resource, who we're going to hear from in a little bit, Michigan Energy Efficiency Contractor Association, Great Lakes Renewable Energy, and our friends over at the Michigan Geothermal Energy Association. Huge thanks to them. And so head over to track 2 right now, which is not this track. I set the link into the chat. If you want to see the tour, Mark Miller, Paula Bueva. Otherwise, right now we're going to be starting a really interactive session that I hope with the fundamentals of high performance building enclosures in new and existing homes. So we're going to be going through and asking questions of Mark Lee here with Better World Builders, and then Michael Klement with Architectural Resource. Mark's going to be focusing on existing homes, renovations, how do we get to them to zero. Michael's going to be on new construction. And so this is going to be interactive. So put your questions into the chat. We want to get to them, and we want to have you engage with us and move forward from there. So Mark, Michael, welcome.
Thank you, Brett. It's a thrill to be here with you for the 2nd annual. Good for you. Good for us. Good for the industry. Good for everybody.
All right.
Yeah,
So go ahead, Mark.
I agree. Hey, glad to be here. Mark Lee, Better World Builders, and congratulations, Brett. It's nice to be part of the 2nd round of the Zero Net Energy Conference.
Yeah, welcome back. Mark was with us last year when we all got to meet in person, so that was great. Mark, I did kick control over to you if you want to put anything up, but really we want to start talking about the building envelope, the thermal envelope, keeping energy in, keeping heat out in the summer, and kind of moving up through those and kind of going through each. So really my question, and I'll start with you, Michael, on the new side is looking at floors, slabs, foundations. What how do you handle that? What's kind of your go-to for that?
Great question, Brett. And we've got a lot of different opportunities out there. When we're thinking about a net zero home and the importance of the envelope, it starts with the ground, right? And then moves its way up. The typical mantra that we use is kind of design guidelines. It's it's always energy modeled to confirm. But we usually look at something like R30 for the below grade spaces, R50 for the above grade walls, and then R70 for the lid. And using that as a guide, there's a variety of different strategies that we use. If we're looking at slab construction, what we're looking at doing is isolating the slab from the earth below it, because as we know from building physics, energy moves from more to less. And so when you're standing on the floor at your 98.6 and the ground underneath you is 55 to 52, the heat's going to go from you down into that slab. So we have different strategies we use depending on our clients' ambitions in terms of the carbon conversation, which is a whole other conversation, but using rigid insulation as a way to isolate that slab and bring that mass into the thermal envelope.
Great, thanks, Michael. And Mark, what about you? What are you looking at there on existing homes, and what are you seeing?
So Michael's spot on as far as the whole envelope. I have a diagram that I think maybe be to share with you on here. Let's see. This idea of that we're talking about, where Michael is pointing out that this particular drawing doesn't really show that insulation down here underneath this slab, but it will make a big difference. We do find that even on the older houses, this is usually just concrete or cinder block walls in here, and then the big part on crawl spaces, there's a lot of energy lost in this whole thing of crawl spaces and actually moisture getting underneath. And once you have excess moisture coming into a house, then you have to deal with that as well. So that just takes more energy to heat, cool, and remove that moisture. So getting that part in control is a real key part. Here's some things that we've run into in basements, and in this diagram you could see there's almost a monster right here in this mold formation on this cinder block wall.
It's the shroud of Turin in the crawl space.
Yeah, yeah, exactly. Can you see that? So in these crawl spaces, there is a ton of energy lost in this. I'm not sure if you've done any modeling on that stuff, Michael. I've done a little bit, but what I have found is that almost like 5,000 BTUs of energy is just, it can be soaked up when you have a crawl space or a basement that's not insulated.
What what's kind of your strategy when the slab's not insulated? I mean, do you typically just leave it alone? It's kind of a lost cause, or?
One of the things we typically will take it when we have just the slab, we'll encapsulate the bottom so we get the moisture at least on one side of that crawl space foundation. At least we can get in control of that. Then we go after the side walls of that crawl space foundation. Those are real susceptible to a lot of the temperature because they're not, those walls are not even down below 4 feet. So once they get down below that 4 feet, like we get to a constant temperature. But those crawl spaces, they usually have a lot more exposed cinder block and a lot more exposed foundation. So getting that ceiling and the dirt out and then insulating the spray foam is one of our techniques that we use. We'll use spray foam on closed cell spray foam on blocks in a crawl space and right along the rim joist as well. That we usually pump up to about anywhere between 15 and 20.
Great.
Brett, I want to jump in here on what Mark was saying about going down the 4 feet. One of the concepts actually from Passive House is the idea of lengthening the thermal bridge. And what Mark was pointing to is the idea if we can lengthen the thermal bridge in that connector of the sidewalls. We've done an awful lot of, I know I'm here representing new, but in our work at AR, we've done a significant, I'd probably say 80% of our historical projects have been remodel, renovation, or new. And one of the things that we've run into, which is a real challenge, is how do you insulate an existing slab on grade when there's no crawl space and no basement. So now you're right there. There's no lengthening of anything. And what we found to be effective is, as Mark has clearly pointed out, which is very accurate, if we can get the thermal temperature of the earth closer to that steady state 55 to 52 by using either skirt insulation that goes around the perimeter of a slab on grade, or in some cases we've done a skirt and dug down 2 feet to create a collar. That can actually go a long way because when we're talking about this, Mark and I and Brett, it's about delta T, right? So, like Ann from California, delta T in California, we've got some delta T to play with. And so if we can reduce that delta T, we can reduce the flux of energy through the assembly. And so that's one of the strategies that we have employed for a slab on grade, which can be a challenge in creating a high performance home in a remodel or renovation situation.
Great. Well, I'm going to throw the next question to you, Michael. And while I'm doing that, Mark, if you can, if you want to expand your PowerPoint down there just so we can see the whole thing when you show us examples.
Okay.
That would be helpful. I didn't realize it was shorter, but so moving up the wall a little bit, looking at the wall assemblies, Michael, just sort of that, above grade wall assemblies. What kind of strategies are you using? What are you liking to use? What don't you like?
I've got to tell you, the above grade wall conversation is what has got us most excited at Architectural Resource of late, because we are looking at so many different opportunities. There are literally a myriad of different possibilities in a new construction situation to create a high performance wall. The default is the Building Science Corporation Joe Stiebrick Perfect Wall, which embraces the concept of continuous insulation. We're actually going to talk more about that in the live guided tour I'm going to share with you after this presentation. But as a preamble to that, one of the things that we're trying to do is to reduce the thermal bridging that takes place in a typical wall assembly. Stud framing, 16, 24 on center, that's just a through conduit for energy transfer through the home. And so what we're looking at is separating or isolating that stud framing, the structure, from a CI, or a continuous insulation wrap, which can be achieved with a myriad of different products, EPS, XPS, rock wool, cork, mineral wool fibers, Gutex wood fiber board. I mean, there are so many different products out there on the market. And when we're specifying it for our clients, we're going to be having a deeper conversation about what their aspirations are in terms of budget, performance, durability, longevity, and carbon. And Anne mentioned that it was on her slide. I'm not sure if she went into it too far, but coming up next in all of our conversations, or should be, is this carbon conversation. And looking at what Brett calls front-loaded carbon, or the upfront burden of carbon, pre-loaded carbon. So the continuous insulation is a tried and true go-to technique, but we're also looking at different strategies that can help reduce the cost of construction. One of the things we're looking very closely at and doing some modeling on and some experimentation with is the good old-fashioned double stud wall, right? Everything old is new again. And so this is something that we're looking at, which has some real potential as far as we're concerned, because if it's not achievable, it's not sustainable. And many of the things that we look at, and we've done some really wonderful projects and done some great things, but our goal, as I know is Mark's, is to push down that barrier to entry so that this becomes ubiquitous. And there's no reason why you wouldn't do it, because the only thing that separates doing it and not doing it is the cost conversation. Once we get that handled, then the only question is going to be, why are you waiting? What's taking you so long?
Right. Thanks, Michael. And Mark, obviously you probably run into a lot of different things in existing homes and walls, but what's kind of your go-to strategy? What are you seeing out there?
Well, it's a great question. I'm going to actually talk about the new construction just for a little bit, because Michael's side it's a terribly interesting side. There are lots of different options out there, from T-studs to ICF, insulated concrete forms, to those SIP panels. They all have some great characteristics to them. But the double studded walls, I had the honor of working at that Paul Abueva project, where he was working on that round house that they're walking on, and there was 14.5-inch double studded wall cavities that we packed full of insulation. There was over how many pounds? There was near 25,000 pounds of cellulose insulation that was packed into that house, and a whole bunch of it went into the double studded wall cavities there. So from a new construction standpoint, great stuff. We haven't really got that, I've never really taken a house to on a wall system, an existing house. Some interesting ones that we have done, we've worked on some 2-brick and 3-brick style houses that's the whole thermal bridge. There's no cavity to insulate. On that wall system, what we did is, on the inside of that wall system, since it was all stone, we took InsoFast panels that has like an R10. There's no studs involved, so it's continuous insulation, so it actually performs a lot better. And we installed that throughout the whole house, and that made a huge difference. It lowered their energy consumption. That those brick walls are soaking up about 20 to 25% of the heat energy during the wintertime. So that was an interesting one. Another thing that we're finding is wall insulation in existing houses really could be just downright crappy. Here's a picture of one, and I have a picture of how we got rid of it. But and Brett, tell me if this is coming up right on your side.
We're not seeing it on our side.
How about now?
It's low.
There you go. Yep.
Okay. So yeah, and you can see that on this slide. This is an 1835 house that we took apart here in Kalamazoo. It's one of the oldest houses in Kalamazoo. They had tried many times to get it right, get the insulation right on this house, and from this yellow kind of rock woolish fiberglass stuff that was really prickly, to some cellulose, to some fiberglass bats. there was about 4 different types of insulation in that house that that we ended up just sucking right out. Actually, here's a little action of us taking that stuff out. And what we're doing here is this one guy is on the greenhouse. He's actually supplying this with air so we can actually blow out that cavity. The guy with the white hose, he has a big vacuum. So he's sucking out all of the stuff out of that wall cavity. And then this gave us an opportunity to repack these walls and do a really nice job. You can see over, this is also in between the first and the second floor. So there's a whole air sealing spot to fill in right in there. So that's just an example of some of the walls of taking walls and changing them up.
You know, Mark, I really, I'm going to jump over across the line again and say a little bit more about remodel.
Yeah, please do.
When you're talking about a
masonry, the houses out there are this way. So
yeah. Well, first of all, hats off to you for the work that you're primarily focused on, which is renovating existing homes. That is our energy legacy, that for all the new homes that we might create at Architectural Resource, they make a zero impact on the existing legacy of homes in America, many of which were built before there were any energy codes whatsoever. So we have this, the elephant in the room is the existing houses that we have. And one of the things that we've done in our, 80% of our work being renovation is we had a really beautiful mid-century modern home. Brett was actually involved with this because this was, I think, Southeast Michigan's first Green Star certified whole house remodel. Beautiful mid-century modern, brick clad. And we wanted to go for a high level of performance on here, Emerald certification. So what we did is because brick is actually a phenomenal weather resistant barrier. I mean, it's a high hydric capacity, it's got drying potential, it's got an airspace, it's like a natural rain screen. Well, we made it a natural rain screen by opening up some head joints so it actually had ventilation and air transfer. But then the question was, how do we insulate a brick veneered home? And many of our attendees may have brick veneered homes. Well, the strategy we came up with was actually going inboard. So we built a literal double stud wall. We decoupled the sill, so we had a gap between, so we eliminate the thermal bridging there. And we lost some square footage on the inside, but the alternate was to remove the brick and all the embodied energy in the brick and build to the outside, because this continuous insulation program that I just got done telling you about was not going to be an option here. So instead we built inboard. We had our drainage plane. We used, in this case, spray foam insulation, and it worked beautifully. So it's what I love about existing condition remodel, renovation, restoration is it really challenges the old gray matter. You really have to reach deep and try to find different ways to make it work. And I love how your team is both pressurizing and depressurizing the cavity to enhance that removal of insulation. Good for you guys.
Yeah, thanks. Yeah, we've had some really great guys that work at Better World Builders. They came up with that way of getting the insulation out. There was a time where we used to use old window weights, like from old window sashes, and we would take those heavy weights and we would actually cut a hole in the top part of the wall cavity, put that weight inside to help push it out, and then down at the bottom have another spot where we're either yanking out or hand removing that insulation. So there's continued innovation as far as trying to find ways to renovate in a creative way that's affordable and accessible.
Well, I'm glad you said windows, Mark. Keep going with that. I mean, for existing homes, what do you do with windows in the walls? I mean, are they a big pain point? Are they not? Do you have to get brand new windows all the time?
Well, in my opinion, it might be a loaded question there because I'm not a big window. I do like windows, but I don't. Excuse me. They're usually only make up like 15% of the house. And when you go from an old window, R1, which is a single pane of glass, put a storm window on it, you got almost R2. You have a new vinyl window, it's maybe R3. And then some are starting to get up closer to 4 and 8 right now, some really, really more exotic ones. And it'll be interesting to see what happens on those. But usually the bigger bang for your buck is actually just taking out the old insulation out of your walls and repacking them, because that accounts for more of like 85%. And most of those walls, existing walls, like some of the pictures that I was showing, those really have an R value of about an R3 or an R5. And if we take out all that old junk out of there and repack them just with cellulose, we're going to yield much closer to R13. So, it's more than 3-4 times the insulation value in 85% of the house. So usually that's my go-to first on that side. Windows do have their place. Don't get me wrong, they can make a tremendous difference. They can also make a difference just in the simple enjoyment of your house, because windows are a big part. We have a relationship with our house. We have a relationship with certain windows. And if you've ever been in an old house, there's that one window that just you have to bang on the left side, bang on the right side, yank on it 3 times, and then it'll open up a little bit. And that's not a relationship you want to have in a house.
Yeah, you can open it all.
Mark, you're bringing up a really great point. We get in our industry, and with Mark, what you do, and Brett, what you lead in the Midwest, we get all dialed into energy modeling and thermal performance and Hertz scores and EUIs and all that stuff. But Mark, you just landed on a really key component, and that is the thermal comfort of a home. It's absolutely true that windows in a renovation situation it's kind of a hard reach to justify the cost of wholesale replacing. I mean, I know that there are companies that do restoration work that basically just come along, they do air sealing around the perimeter, they put in spring gasketing, they put a storm on it, and they are achieving with historic windows energy performance commensurate with new high performance windows. But
right.
The thing that's so different is that radiant exchange, right? The emissivity component, because in the old windows, there's no low E going on. And so you could be sitting next to a new window and an old window with the same R value of performance, but the energy flux between you and the window, many times when we think we're experiencing a draft, what we're really experiencing is that energy flux of the energy moving through radiant exchange from you to the window. And the colder the window is, and the warmer you are, the more you're going to feel that. But even in my own house, a mid-century modern, and we've got lots of glass, it just didn't pencil to have us go through the effort of replacing the windows relative to the walls. Exactly what you're sharing here. I mean, that's such a key component. Now, in a new construction situation, it's a little different, because now we're using the windows in our arsenal of energy generation.
Right.
Now we can actually put them to work and have them earn their keep by being very careful with the orientation of the building, the overhangs that are protecting the windows against high summer sun and emitting low. We're going to talk about this in our next presentation. And something called solar heat gain coefficient, or the amount of energy that's actually emitted into the window. And I remember being taught by the Dean of the College of Architecture at Michigan. He said any southern window, properly shaded, will be a net energy producer as opposed to a net energy loser if it's a southern facing window. East, west, and north, all bets are off. But in new construction, and this is where we can absolutely model it and change the parameters of the windows and see how it specifically and directly affects performance. But that becomes, it's no longer the enemy. Now the windows become our friends.
I like this comment that came in that takes a little bit more in depth, another look at windows, and they brought up triple pane. They said triple pane's what I go to. I'll settle for nothing less. But they mentioned noise, as a noise barrier, a noise blocker, which is a comfort issue. So obviously they can play that comfort role. But Michael, you do a lot of new construction. Does it have to be triple pane to get to net zero and passive house? Is that the truth?
Well, that's a great question, because we're actually looking at that right now in a project that we're in design in. And the usual go-to is the triple pane window. And I would say for passive house, that's typically what we're looking at. But the house I'm going to share with you next is net zero, right? So there's a difference between passive house and net zero. And that house uses double pane glazing. In some cases, we're using triple, but what we're able to do, and the participant is absolutely correct in terms of the sound benefit. I mean, when Mark gets done with the house, I am certain that his clients notice when they walk in the significant difference in terms of sound transfer. And that goes again to that there's the intangible aspects of a high performance home that aren't just measured in terms of EUI and kBTU per year. We don't want to forget that ultimately we're creating the home that you're going to live your life in. Yes, energy is important, but there's a myriad of other factors that lead to an enjoyable life in that home.
Yeah.
Mark, so keeping on the exterior wall, I mean, somebody was mentioning here about, wrapping a home up in rigid insulation, whether it be mineral wool or, foam. What are your thoughts there? Is that just, too much effort, too much work, too much cost, or is it something you see or do sometimes?
It's definitely something we see. We sometimes do, but the one of the key underlying aspects of it is if you're going to add more insulation on top of a wall system, you got to look at the baseline wall system first. So the baseline wall system, meaning the original, usually a 2x4 wall, sometimes a 2x6 wall, but from the drywall stud to the exterior sheathing. If you are replacing your siding, great time to add some extra insulation. But before you just add additional extra insulation on the exterior on top of your OSB, a really critical part is actually to get inside the existing wall cavity and change out that insulation. If it's fiberglass, a lot of times I have a whole bunch of infrared pictures that I didn't bring on this one, but on another presentation I have where you could actually see, you could take an infrared imaging camera and you can actually see like little mouse tunnels going through the fiberglass insulation. And because a lot of old houses or existing houses never were sealed up right, they end up getting rodents. Rodents that kind of come into the house. They'll enter at the rim joist. They'll climb up either an interior wall or an exterior wall, and then get up in the attic, and then they have free reign over the house. But the wall insulation that is existing in houses, it's really, I feel it's pretty absolutely critical if you're going to go through the expense and effort of adding additional exterior wall insulation when you're siding a house, to go in and address and amend the original insulation that house had. Most of the time it's if a house was built in the 50s, I mean, we're talking about 70-year-old insulation that's been sitting in that wall, and it's seen many things that pass through it. So that's just kind of talking about that wall side. That's certainly a piece where if you're going to go through that expense to get rid of thermal bridging, great, but address the inside first.
Great. So if we want to, move up from the walls to the roofing, Mark, what are you seeing for, fixing existing homes from, attic, whether it be attic floor, whether it be on the roof deck, what are you seeing out there? What are you recommending?
Once again, I come back a little bit to coming back to the whole idea of retrofitting spaces. Attics have they historically have a lot of rodents and creatures and other things that are, we actually have this saying right now about, it's near Halloween, so we've been asking the question, what monsters are in your attic? And some of the monsters actually can be old knob and tube wiring, asbestos or vermiculite insulation. Then there's usually a lasagna layers of different insulations in there, typically some old blown-in fiberglass that's been exposed to the elements for 20, 30, 40 years. It ends up that those spun pieces of glass become real brittle, and it ends up breaking down to its base constituent in sand, and it's just kind of these little tiny shards of glass that are in attic spaces. So if you can imagine, you have an attic that has some old fiberglass in it, and you have a ceiling fixture or a light switch, and you have a windy day, or a jet goes overhead, or a truck drives by in front of your house, or the thunder even shakes your house a little bit. Every time one of those events happen, a little bit of that dust starts to enter into your home environment. So we have found like one of the best prescriptions to make on that is actually suck out all of the whole attic insulation, get rid of all the old fiberglass, get rid of all the dead animals and their excrement and everything else that they've left over. seal up the attic floor. We actually have started to do a mold treatment in all of our attic spaces because we have a special chemical it's an antibacterial, antifungal, antiviral, and urine neutralizing non-toxic hydrogen peroxide based chemical that we spray into attic spaces as we're working in there. And it actually creates our environment a little bit better for us when we're inside there, even though we're wearing respirators. It makes it a lot cleaner. But then once we get rid of all that insulation, we will seal it up with, we'll spray some more of that material down just to help neutralize things, and then seal up the attic floor. I have a new thing that we've been coming across is doing this. Are you seeing can you see my pictures right now? Am I sharing my screen with you?
Yes, we can.
Yep.
Yes?
Yes.
Yeah, so in this, if you're able to see this, this is a cathedral ceiling, and this is one of the things that we've been finding when we have an opportunity to re-roof a house on a cathedral ceiling. We'll take out all of the old fiberglass. This old fiberglass here, we just pull that out, and then we'll start to air seal and foam this area. You can see right in here, there's actually some wall cavities that were stuffed, some interior wall cavities that were stuffed, and those are now sealed during this process of using a closed cell spray foam on this area up here. So that's some of the things that we're doing with attics these days, and I'll tell you what, when you take this approach, you really can make a great difference on the inside of the house.
Michael, what's your go-to for roofing? I mean, you kind of get a fresh slate, a fresh palette to start with, right? With whatever you want to do. So what is it that you're usually up to?
Yeah, and I'll kind of circle back to Mark's field a little bit here at the onset. And one of the keys that we always find in terms of retrofit situation, I'm sure Mark has struggled with this in his career, is the heel, where the roof comes down and meets the outside wall. And boy, oh boy, I mean, when you've got a 3.5-inch space to try to make something happen and avoid ice damming and condensation on the interior surfaces, because as you increase the R value in certain areas, that means relativity, the other areas are going to be colder. And so that same interior humidity that was perfectly fine is now going to find spaces because you've emphasized the difference, the delta in those cavities. So one of the challenges that we always find, whether it's new or remodel, is the conversation of, is it going to be a vented attic, or is it going to be a hot attic or a hot roof? And for those of you who aren't familiar with that, what that means is most of our attic cavities have insulation at the ceiling plane, and then above it we have open air, which is essentially, ideally, ambient air. So it allows ventilation. Another way to build a roof is to bring that thermal envelope from the roof, from the ceiling, up to the roof plane. And that's what Mark was showing on the cathedral ceiling there. He was putting in a flash and bat system where you're putting in the air sealing down there. So the foundational question is always, what type of base roof do you want, ventilated or non-ventilated? And you have different questions and different challenges depending on what that answer is, depending on your situation. In this next project that I'm going to share with you in a live guided virtual tour, we are using cathedral ceilings, but we're using a product called structural insulated panel, SIP. And I'll say more about that, because what becomes particularly key, and I know Mark is all over this, is being mindful of the moisture drive into your attic spaces. Because although heat moves from more to less, warm air is buoyant. And actually, the more humidified the air, the more buoyant it is, which might be counterintuitive. At least it was for me in my simple brain when I was figuring it out. But the higher the relative humidity, the more buoyant the air is. And so you have to be really on your game in terms of controlling humidity, penetrating into that lid. And again, we're going to share a lot more about one approach we took to that in a very high moisture load situation where we had a recirculating swimming pool inside a home. Talk about moisture load. That was
well, Michael, I'm glad you said humidity, because there's some questions, some comments coming in here, not just about humidity with water in the air, but permeability and water getting into the walls, wetting the walls, causing damage. So Mark, I mean, what kind of concerns do you need to address, not just to increase energy efficiency, but to ensure that, you're not having a rotting building with what you put in there as well?
Yeah, so a lot of it comes down to that basic building science. There is a test that we could do to find out the tightness of a house. So once we know where that tightness is, then okay, if a house is over that tight level, then we make sure that we're doing our exhaust ventilation. A key thing when we do a lot of attics and renovations, most of these houses, once again, they've had that same bathroom fan in that house for like 15 years, and they turn it on and it starts off and it makes a whirly noise, and then it starts to go kind of funny, and then it doesn't really suck any moisture out. That's a sign that you don't have a performing house. So one of the things that we do when we're doing a retrofit is we'll not only take out all that attic insulation, seal up the attic floor, but then we'll also take that opportunity to install proper exhausting bathroom fans. One of our go-to fan right now is the Panasonic Whisper Sense fan. So we use this product, in 90% of the fans that we put in, they put in a Whisper Sense. The key part about the Whisper Sense is that it has a sensor on it. It has a motion sensor as well as a humidity sensor. So we'll make sure that when we commission or baseline, or after our work is done and we're commissioning the retrofit work, we'll usually set those bath fans at a between 50 and 55 relative humidity setting, and then like a 10-minute motion sensing. So that helps pull a lot of that stale air out of the bathroom area and helps control the moisture. The next step, if we find that the house has gotten extremely tight, and we also kitchen ventilation is a very key part. And when you're in these tight houses, if you're not exhausting out your kitchen ventilation, you are doing yourself and the indoor air quality a great disservice. Every time you fry up a steak on the stovetop or something along that line, you're emitting a lot of those cooking oils, and they're just atomizing into your air system. So in a tight house, that indoor air pollution you created when you're cooking, if you don't have a good kitchen exhaust fan, it will certainly linger in your house a lot longer. We've been doing some tests with air monitoring, and you can always tell when somebody is cooking in the house with these continuous air monitors. You'll see like the particulate matter start to spike up. The next method that we use after just simple exhaust fans, bathroom and kitchen, then we start to get into energy recovery ventilators, which are in the retrofit world, it's a great thing to tie into your existing furnace, and we typically like to try to create a new pickup location for it to pull the stale air out. Sometimes we try to aim for the kitchen because that's usually a warmer, moisture place, so we could pull out some of that air and run that through the energy recovery ventilator. Then we can bring in some fresh air to help spread that around. But that's certainly a key part in keeping that indoor air quality tight and healthy.
Yeah, absolutely. And I'm glad you brought that up. We've got about 7 minutes over here before we transition, but did want to talk about air leakage, right? So not just stopping from a thermal performance, but also stopping, the convection, the air leaking through our walls. Obviously, ventilation is a key point of helping, move that air intentionally when we have a tighter house. But Michael, what are some of the challenges and opportunities to air sealing homes? How low are you getting them? What methods are you using?
Yeah, boy, I'm glad that we're ending on this, because we're learning in the building sciences that there are 4 control layers in our walls. The first is the bulk water control. The second is the air control. The third is the humidity or moisture control. And the fourth is the thermal control. And from studies at the foot of Joist, we've learned that is the order in which you want to consider your walls. And so when you're a walls, roof, it's something, it doesn't matter what it is, we're talking about the building envelope, bulk water, air, moisture, and then last but not least, thermal. And if you're not on your game in terms of the air control, particularly when you turn up the dial on the resistance of energy flow with higher R values, you have a recipe for disaster. So the air control layer becomes extremely important. And there's a myriad of materials and properties that we can use for air control. But where it really comes together, where the pedal meets the metal, is where materials meet, at the junction between things. And that's where the skill set and diligence of our team really comes to bear. Because if that's not looked at, I don't care what kind of an amazing, Intello or whatever you have, it's where everything comes together is where the challenges is. And you have to really be on top of that. Not only is it 30 to 50% of the energy loss of our building, but it's a phenomenal way to have your buildings develop mold, rot, mildew, and collapse, leading to dead clients, which I've learned is not a good idea for business, is what they're telling me. So trying to avoid that in all cases is not a bad idea.
And yeah, Mark, you just want to wrap us up with some of the air sealing things you're seeing out there.
Yeah, so some of the air sealing things we see out there, the thing that Michael brought up and really nailed as far as moist air rises is a really key part. We do find up in attic systems, it was amazing. I've been in a couple attics just this past week where there's been so much mold accumulation on the underside of the roof deck. So you have all this mold growing, and a lot of homeowners don't even realize it because it's you look up at your ceiling looks fine. You go up, you climb up into that attic, and then you look up at the roof deck, the underside of the roof, and what you see is all this mold growth. I've been finding a lot of that, and if the air sealing techniques of going through and sealing up that attic floor, we typically recommend wherever there's a plumbing stack, you're going to seal around that. Typically, we find around chimney areas, you'll flash around that and then use a special high temp foam or high temp sealant there to seal those things up. Usually we use a metal flashing, and then we're just sealing up the edge with a high temp caulk. Then we go around through all the top plates and any penetrations where the top plates are, and any penetrations inside those top plates for lighting chases or electrical chases, we seal those up. There's a lot to seal up in an attic. Usually when we do a blower door test from a baseline regular standard house not sealed to an attic that is sealed, usually we could see an easy 30% drop. On story and a half houses, when we do a story and a half house correctly, that's like a typical Cape Cod style retrofit. Those are notoriously kind of uncomfortable in certain areas, but we just finished a Cape Cod. It was all brick on the outside, but they had a story and a half, so it had a knee wall and then these floor cavities between the first and the second floor that were open. It allowed a lot of heat to escape there. We sealed up that house by 57%, getting underneath the floor cavities between the first and the second floor in that knee wall attic space. Very key spot. Sealing up the knee wall itself and making sure like the electrical penetrations where the outlets are, and then all throughout that whole system there. That's a key part. From sealing up on walls, usually one of our ways of sealing up walls is by dense packing them with cellulose, extracting out the old insulation, dense packing them with cellulose. When we do walls, we can also see a 20% infiltration reduction. But even before that, a less expensive way to address the ceiling of a house is we usually go attic, then rim joist. The rim joist being right where the cement part of the wall meets with the wood part of the house. That's typically what we call the rim joist. Well, there's a lot of air that actually gets sucked in during the wintertime. A lot of air gets sucked in right at that rim joist. If no one says this is a great idea where a visual of, if you can imagine, for every cubic foot, for every 1 foot of cubic air that rises up and leaves the house through an attic system, another cubic foot of air has to come in to displace that. And usually that's sucked in, it's actually drawn in right around the rim joist of a house. A way for anyone to check that is to just actually look at the pull some fiberglass insulation right out of your rim joist and just turn it over. And a lot of times you'll see this dark band of dirt right on the piece of yellow fiberglass. If you see that, then you know you got some air leaking in right there.
Great. Well, Mark, Michael, we are at our time. The next track is starting. We've got in track 2 coming up next, we've got Siggy Coco and Lucas Johnson talking about embodied energy.